Welcome once again to Domoji Math and Science. In today's lesson, we will look at trigonometry. Trigonometry helps us solve our triangles. There are different types of triangles, but for today's class, our focus will be on the right angle triangle. In subsequent classes, we will explain on how to solve for other types of triangles. But for today, let's understand the right angle triangle. If I have a right angle triangle this way, one unique characteristic of a right angle triangle is that the edge, or I should say one of its angles, must be 90 degrees. This sign here illustrates 90 degrees. If I have it this way, I could have a right angle triangle coming this way. The moment I have this shape here, it tells me that this is a right angle triangle, this is a right angle triangle. While this edge has 90, this edge also has what? 90 degrees. That makes it a right angle triangle. If I have the shape this way, and I still have my symbol this way, this is also a right angle what? Anytime you solving a right angle triangle, I want you to have two unique formulas at your fingertips. The first formula you should have at your fingertip is what I will call SOHCAHTOA. That is number one. The second formula I want you to have again is what I will call my Pythagoras theorem. Now you must have these two formulas at your finger to help us understand these two formulas. I want us to understand the right angle triangle properly. Let us learn to label the right angle triangle. Like we explained, this part here tells me that this triangle is a right angle triangle. Let's call this triangle A, B, and C. If this is triangle A, B, and C, there is one unique part on this triangle, and that is the longest side of the triangle. That is called my hypotenuse. Now I am left with two other sides of the triangle. These two other sides of the triangle, I label them depending on the angle with which I am talking about. If I am talking about the angle at A, this side becomes the opposite to A. I call this my what? Opposite. This side becomes the adjacent to A. I call this my what? Adjacent. So that, let me write it in brief. And this is my hypotenuse. Now, if I am going to talk about the angle at C, let's draw the triangle. Remember, this is my triangle A, B, and C. Here is my hypotenuse. Now, if I'm talking about the angle at C, in this triangle, my focus was the angle at where? At A. But here I am focusing at the angle at C. If I'm talking about the angle at C, this side opposite C becomes my what? Opposite. And this side beside C here is called my what? Adjacent. Now this side is called my what? Adjacent. So that with respect to any of the angles, you can label your right angled triangle. Let's get started with our Pythagoras. See how to solve with your Pythagoras. Still using triangle A, B, and C. You remember that this is my hypotenuse. That is the longest side of the triangle. So that if this is my hypotenuse, I will decide to label this part, call this part my small b, this side, and call this side my small c. Here is the big C. And call this side opposite here my small what? Small a. Pythagoras theorem states that this longest side, the square of the longest side, is equals to a squared plus what? C squared. That is b squared is equals to a squared plus c squared. So that if I have a triangle A, B, C, I have this side to be 4, I have this side to be 3. This obviously is my B. Pythagoras theorem tells us that my B squared will be equals to 4 squared plus 3 squared. So that my B squared will be equals to 4 squared is 16 plus 3, that's 9. That's equals to 25. My B is equals to the root of 25, which is equals to what? 5. That is, this side will be called what? 5. Now let's see the second formula that is so essential. And that is what? That is our sine, cosine, and your tangent. Now, a good abbreviation of this is your SOHCAHTOA. It tells me that from here, the first one is the x. That is, my s is sine theta. Sine of an angle. Let's call this angle theta. Sine of this angle is equal to the opposite all over your what? Hypotenuse. That is, if I am taking the sine of angle at A, it will be equal to my opposite over hypotenuse. That is, it will be equal to my small a over b. If I'm going to take the cosine of this angle at A, it's equal to opposite, SOHCAHTOA. If I'm taking the cosine, that was a mistake, this is CA. If I'm taking the opposite, if I'm taking the cosine of this angle at A, it becomes my adjacent over hypotenuse. That will be equal to C over B. And at the same time, if I'm taking the tan of that same angle, it's equal to opposite over adjacent. That will be equal to A over C. Now, with these two basic formulas, you should be able to solve any right angle triangle. Let's take a look at some few examples before we call it a day. In this example, you can see a triangle labeled A, B, and C. The side here is 6. We have to solve for angle at A. This side here is 6, this side is 8, and this side is 10. Considering the angle at A, my 6 is obviously the adjacent, and my 8 is the opposite, while the 10 remains the hypotenuse. So I can decide to take any of the two, whether your sine or your cosine. If I decide to define it in the form of sine, sine says sine theta, or let's put A. Since I'm talking about the angle at A, sine of A will be equal to opposite all over hypotenuse. That's equal to 8 over 10. A is equal to sine A is equal to 0.8. From my calculator, we can just look for the sine inverse of 0.8. A, obviously, this implies that A will be equal to sine inverse of 0.8. And A will be equal to 53.1 degrees. If we decide to go by the route of using cos A, cosine. Cosine says cosine cos of theta is same thing as adjacent. Now let's solve with cosine. Cos of theta is the same thing as adjacent over hypotenuse. So that cos A will be equals to 6 over 10. That's equal to 0.6. A is the cos inverse of 0.6. Now, with our calculator, you can either use your calculator or your 4-figure table. The cos inverse of 0.6 is something as 53.1 degrees. So whichever route you decide to take, you'll get the same thing. You can also use tan. Tan theta says is equal to opposite over adjacent. So that tan A is equal to opposite of tan A is 8 over 6. That's equal to 4 over 3, which is equal to 1.33. Now you can now take the tan inverse of 1.33. Obviously to still be the same thing as what? 53.1 degrees. Now, thank you for staying with us. If this is your first time of meeting us, kindly hit the subscribe button and subscribe to our channel. See you in our next class.